Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we'll be looking at forecasting uncertainty, and we'll be doing this using the scenario analysis technique. So as we discussed, engineers like to quantify whatever it is we're talking about, in this case, risk. And we have several techniques that we can use: scenario analysis, sensitivity analysis, and probabilistic techniques. Today, we're talking about the scenario analysis. Now, you'll recall that each of the various quantities that we are putting together into our profitability analysis has inherently some error. We could have overestimated, we could have fallen short in our estimates. And this table here shows typical values of what one might expect based on our planning stage. How can I use this to create scenarios that will help me understand what's the best that can happen and what's the worst that can happen? So we're going to want to look at the extremes and our design or our base case. And so generally what you want to do is look at the combinations of all of our expenses and all of our income and see what's better and what's worse. Now, the reality is that, things like revenue, a smaller number is bad and a larger number is better. So that would be your worst case and best case for revenue. For fixed capital investment, we would probably prefer to have a smaller value, and so that's going to be our best case. And if it turned out to be more expensive, that would be a worst case. Sometimes things like the interest rate gets very confusing on whether or not, how is it going to affect the entire project, best case and worst case. So you can look at just three simple cases: the worst combination, the best combination, and the design or base case combination. But in reality, with just these three values, revenue, cost of manufacturing, and fixed capital investment, I have three scenarios that have a worst possibility, a best possibility, and the base case. That creates 27 possible combinations. And if you go back and look at this slide again, what you see is that I have an awful lot of variables. And if I limit myself to only base, best, and worst case, I get a lot of combinations possible. Now, the reality is I only want to look at the one that's the combination of all of the worsts and all of the bests and the base in practice. In this example from the textbook, they actually, for this, looked at all of the possible combinations, okay, for the problem that they've been chasing throughout this. And what they found was that their scenario 9, where the revenue was short 20%, the cost of manufacturing was over 10%, and the fixed capital investment was over 30%, that this was their worst case. Their best case was where the revenue was 5% higher than predicted, and the cost of manufacturing 10% lower, and the fixed capital investment 20% lower. And when they did those economic analyses, they found that their worst case had a negative $60 million net present value, and their best case had a positive $53 million present value. Now, their design showed a $17 million present value. Having the worst case and the best case helps you get a feeling for what could go wrong. And in this particular case, just based on these three numbers, my personal tendency, being a little risk adverse, is that maybe this isn't such a good idea. I would not want to lose more than I could possibly make, okay? But maybe there are some better ways of analyzing or quantifying our risk. So we'll be looking at those in future episodes. Thank you.